You're scrolling through your phone right now, watching videos, checking messages, buying stuff you probably don't need. But here's the weird thing nobody talks about. You're literally sending invisible requests to computers miles away, and they're sending back millions of tiny pieces of information that somehow reassemble into that perfect cat video on your screen, all in less time than it takes you to blink. What is the internet really, and how does this impossible thing actually work? I'm Tim, and today we're going to strip away the technical nonsense and understand the internet using one simple idea that'll make everything click. And quick favor, if you like tech explained without the headache, hit subscribe. I make these confusing everyday systems feel obvious so you can actually use them with confidence. Because here's what's wild. Most people think the internet is some mystical cloud floating around us, but the reality is far more fascinating and surprisingly physical than you'd ever imagine. Let's start by destroying the biggest myth about the internet. Ready for this? The internet isn't magical, it's not floating above your head, and the cloud isn't some invisible sky place. The internet is mostly just a massive collection of cables, machines, and buildings full of computers, physical wires running under streets across countries and even lying on the ocean floor connecting continents, plus giant data centers where the cloud actually lives. Think about this for a second. When you send a message to someone far away, a huge chunk of that trip often happens through real fiber optic cables, and for international traffic, that often includes undersea cables. Not magic, not vibes, just physical infrastructure that people had to build, maintain, and protect. But wait, people say, what about wireless? What about Wi-Fi and cellular networks? Here's the surprise. Even when you're using Wi-Fi or cellular, you're still ultimately connecting back into those same wired networks. Wireless is usually just the first and last part of the journey. Wi-Fi is the last few feet between your phone and your router. Cellular is the first hop between your phone and a nearby cell tower. After that, your data is almost always riding on cables again. It's like having the world's longest garden hose that ends in a sprinkler. The sprinkler sprays for the final bit, but the water still traveled through a hose to get there. So let me give you this model that makes everything obvious. Think of the internet as the world's most elaborate postal system, but instead of delivering letters and boxes, it delivers digital information. First, you have the post offices. In internet terms, these are servers. A server is basically a computer that's always on, usually sitting in a data center somewhere, and its job is to store stuff and hand it out when people ask. Every website, every video, every photo you've ever seen online lives on servers somewhere. Sometimes the server is far away, sometimes it's surprisingly close because many companies place copies of popular content in nearby cities so it arrives faster. Then you have your device, your phone, or laptop, which is like you, the person asking for mail. In technical terms, your device is a client. You request, servers respond. Simple relationship. You ask, they give. But here's where it gets interesting. How does the server know where to send your cat video? How does it find your specific phone out of billions of devices? This is where addresses come in. Every connection on the internet uses addresses called IP addresses. Think of an IP address like a mailing address for where data should go. Here's the part most people never hear. Your phone often has a private address inside your home network, and your router has the public address that the rest of the internet sees. Your router is like the front desk of an apartment building. It receives deliveries for the whole building, then directs each package to the right apartment. Without this addressing system, sending information online would be like trying to mail a letter to someone named Bob, who lives somewhere on Earth. It would never arrive. Now here's where the postal analogy gets really clever. When you request a large file like a video, the server doesn't try to send the whole thing as one giant blob. Instead, it breaks it into thousands of tiny pieces called packets. Think of it like mailing a 1,000-piece jigsaw puzzle. You don't ship the puzzle already assembled. You ship lots of small pieces, and each one carries information that helps it get delivered and reassembled. Those packets can travel separately. Some take one route, some take another. The goal is that enough arrive quickly, and if some get lost, the system can resend them. So how do packets find their way across the world? This is where routers come in. Routers are like the sorting machines and postal workers at every intersection. When a packet arrives, the router looks at its destination and decides where to send it next. If one path is crowded or broken, packets can take a different path. That's a big reason the internet is so resilient. There isn't just one road, there are many. And how do these packets travel so incredibly fast? Most long-distance connections use fiber optic cables. These are thin strands of glass that carry information as pulses of light. Your cat video is literally turned into a stream of light signals that shoot through glass at an insane speed. Not quite the full speed of light like in space, but still fast enough to feel like magic. Now, your packets have traveled through cables and routers and networks owned by different companies. They eventually reach your internet provider, then your neighborhood, then your home, and finally your router. But your phone isn't plugged into the wall, right? That's where Wi-Fi comes in, and I need to clear up another huge misconception. Wi-Fi is not the internet. Wi-Fi is just the wireless connection between your device and your router. The internet is the entire global network beyond that router. Your internet service provider connects your home to the wider network, usually through a cable that runs to your building or nearby equipment. Your router then shares that connection with your devices, either by cable or by Wi-Fi. Wi-Fi is just the last few feet of a much longer journey. There's one more piece that makes this whole system human-friendly. When you want to watch a video, you don't type a bunch of numbers. You type a name like funnycats.com, but the internet's routing system runs on numbers, so we need a translator. That translator is DNS, the domain name system. Think of DNS as the internet's phone book. When you type a website name, your device asks a DNS server, "What's the number for this name?" DNS replies with the IP address. Then your device knows where to send the request. It's like calling mom instead of memorizing her full phone number. Let me walk you through the complete journey now. You're on your couch. You type funnycats.com. Your phone asks DNS for the IP address. DNS replies with the numbers. Now your phone sends a request toward that server saying, "Please send me the cat video." The server says, "Sure." It breaks the video into packets. Each packet gets labeled so it can find your network and get reassembled in the right order. Those packets travel across routers and cables, sometimes across continents, sometimes under oceans, sometimes through nearby caching servers that are placed closer to you on purpose. They reach your internet provider, reach your home, reach your router, and then your router sends them over Wi-Fi for the last few feet to your phone. Your phone collects the packets, reorders them if they arrived out of sequence, asks for any missing pieces, and then rebuilds the video so smoothly you never even notice the chaos underneath. Suddenly, a cat appears on your screen doing something ridiculous, and you laugh for 15 seconds. And the whole trip was basically a hyper-fast postal service powered by light. So what does this mean for you in real life? Understanding how the internet works changes how you think about everyday problems. If your internet is slow, now you know there are dozens of possible bottlenecks. It might be your Wi-Fi, it might be your router, it might be your provider, it might be a busy route somewhere far away. It's honestly amazing it works as well as it does. If you're concerned about privacy, remember that your data travels through lots of systems on the way to a destination. That's why secure connections use encryption. When a site uses HTTPS, your data is scrambled so that even if someone intercepts it, they can't read the contents. They can often still see that you connected to a service, but not what you said inside the conversation. If your Wi-Fi keeps dropping, you now know Wi-Fi is only one small link in the chain. Sometimes the issue is local. Sometimes everything outside your house is fine, and it's just the wireless part struggling. Other times, your Wi-Fi is perfect, but the wider connection beyond your home is the part having a bad day. And if you're amazed by how fast the internet is, remember what we're really doing. We're sending information around the planet using light through glass, guided by a giant network of digital sorting machines. The main limits are distance, congestion, and physics. If you ever feel like tech is too complicated, hold on to this. The internet is a really fast mail system. Requests go out, responses come back, big things get split into smaller pieces. Those pieces take whatever routes work best. Then your device puts everything back together like nothing happened. Here's my simple framework for any internet mystery. Ask yourself, is this a local connection issue between my device and the router? Is it a name and address issue where the request can't find the right destination? Is it a network traffic issue where packets are delayed or dropped in the middle? Or is it a service issue where the server on the other end is overloaded? Most internet problems become way less mysterious when you remember it's all just a global delivery system made of cables, routers, servers, and light. The internet isn't magic, it's millions of computers connected by real infrastructure, talking using addresses, breaking big files into packets, and delivering them fast enough to feel impossible. Simple as that. You're no longer someone who just uses the internet. You're someone who actually gets how it works. And that's a pretty powerful thing to understand about the world you live in. If this made the internet finally click, subscribe for more explanations that make complex tech feel obvious. Next time, I'll break down how your phone knows where you are, and the real answer is way more interesting than most people expect.